We are really excited to have Nicole Sintov here. She is an associate professor of behavioral decision-making and sustainability in the School of Environmental and Natural Resources. She's actually an environmental psychologist by training, so she has a PhD in psychology. We were just talking, we got her here from California, which, you know, to get her to come to OSU from one sunny place is a little hard. She's an interdisciplinary scientist, does a lot of quantitative work, experimental research. She's got some really prestigious funding. So she's NSF funding, Department of Energy funding. And I liked seeing that you have the World Wildlife funding, Nicole. That was pretty darn cool. So she has a World Wildlife Foundation funding. So a lot of different grants. She's also currently the director of the Environmental and Social Sustainability Lab here at OSU. She's been a member of the Decision Sciences Collaborative. Some of our doc students before in the past have really benefited from mentorship and advice, who are doing work in behavioral decision making or environmental psychology, environmental decision making. So hopefully we'll be we're excited for her talk, and we can give her a warm welcome here at the college. And as with before, feel free to interrupt with any clarifying questions. If you've got major substantive comments, you can hold it till the end for some more robust discussion. So with that, I'll turn it over to you, Nicole.
Thank you. Thank you so much for having me. I'm excited to be here. And as Stephanie mentioned, I'm a psychologist by training. And so what I'm going to be presenting today are results from some published papers that are a couple years old, but I thought this would be most relevant for this audience, who are probably more interested in bigger picture things than kind of what I tend to focus on as a psychologist, really studying like the nitty-gritty details of people's behavior. So today I'm going to be talking about consumers and residential demand-side response programs in the electric grid. And are you guys going to be monitoring the chat, or should I do that?
We'll do that. We'll do that for you.
Okay, awesome. Thank you. Okay. So demand-side response in the electric grid. This engages electricity consumers to shift or reduce their demand to better match available supply, for those who aren't aware. And the reason that we want to do this is to increase demand flexibility at certain times, because solar energy is only available when the sun is shining, and wind energy only when the wind is blowing. We want to be able to facilitate integration of these intermittent renewables, and we can better do that by making demand flexible. So one measure that utilities are increasingly using are called time of use rates. And these are special electric rates that aim to shift usage away from high demand on-peak times by charging more per kilowatt hour during those on-peak times and less money during off-peak times. And so here is a little schematic of the rates that we actually looked at in the studies that I'm going to go over. And so what you see here is that there are different costs set for on-peak versus off-peak times. There are two different rates here that we're looking at. Mornings are generally off-peak, and then there's an on-peak time in the afternoons. Night is also off-peak. Those are weekdays. When we look at the on-peak times, we see that they vary both in duration from 3 to 6 hours, with rate 2 being a 3-hour on-peak, rate 1 being a 6-hour on-peak. And then they also vary in terms of the cost of the on-peak. So relative to the off-peak, rate 1 is only 9 cents per kilowatt hour more, versus rate 2 is 30 cents per kilowatt hour more than the baseline. And so these are just examples. They are what we used in the studies I'm going over, but there are plenty of other ways to create a static time of use rate. Okay. So we might be wondering, why do we care about flexibility? And what I'm showing here is the net load on the California electric system. And this is demand minus renewable generation supply. The y-axis is demand, the x-axis is hour of the day, and this is just a random day, March 31st, throughout the years from 2012 to 2020. And this is known as the duck curve, and we can see that if we look at the 2012 year, the gray line on the graph, we see that there's an increase in usage around 9 a.m. When people are getting up, going to work, kind of a decrease around noon into the afternoon, and then a pretty big peak in the evening. And as we go down all the way to 2020, we see that there's a big dip during the day from 9 till about 6. And that's because California is a state that has lots of solar on their grid. And as solar has become more and more plentiful, we're able to integrate it more. And this is net load. So we're looking at demand minus supply on the y-axis. And so what we want to try and do is get people using energy in the state while solar is available and decrease usage during that early evening spike, because when that spike happens, we're firing up coal power plants / continuing to use them, and that's what we want to try and avoid. Okay, so there has been plenty of research on time of use rates and their efficacy. Prior work does find that static time of use rates usually prompts shifting to off-peak use. People don't want to pay more. However, this rate assumes a rational actor model and assumes that people are making these day-to-day decisions based on actual financial returns and kind of figuring out, like, should I run my laundry right now when I am going to be charged potentially 30 cents per kilowatt hour more? People may be doing that, but probably not to the extent that we might want to or expect them to. Prior work also finds that expectations of monetary savings predict enrollment in time of use pilots, and fear of bills, increased bills, that is, dampens willingness to enroll in time of use. And what I want to emphasize here as a psychologist is that these works are focusing on expectations and fear. These are perceptions. They're not what's actually happening. It's what people think is going to happen. And as a psychologist, these are the types of things that I like to focus on. So when we're looking at a time of use and people's willingness to enroll in such a program or stick on it, as we examine in the current study, what people have to do is generate a representation of perceived savings, perceived electricity savings, perceived bill savings. And that involves recall of actual savings. And people typically have a pretty poor understanding of their energy use. They're unlikely to recall bills from previous and even current years. Perceptions of electricity and water use have repeatedly been found to be inaccurate. And people often believe that baseline usage allows savings on time of use, even when this is incorrect. And so in the context of this, when we're thinking about people's ability to generate a representation of perceived savings, this is the attempted recall of actual savings. And this is affected by cognitive processes, including recall. And people must also include their recall of a previous bill and a current bill and compare them. And that's really assuming that people are able to keep a lot in working memory and accurately kind of calculate out what the net savings might be. And our theory is that people may not be very good at this. And so our challenge here is to understand how perceptions filter observables, actual changes in bills and usage, to influence the acceptance of time of use and other demand-side response measures. And so our research questions are the following. We're asking the extent to which residents' perceptions of savings and demand-side response programs reflect their actual change in bills and usage. So how good are we at actually knowing what we're saving? And we're also wanting to know how do perceptions of savings influence participation in demand-side response programs. And so these findings were published in Nature Energy, along with my co-author, Lee White, who was a postdoc here at OSU, who's now gone on to a fellow position at the Australian National University. And our method for this first study, we worked with a large California utility who piloted a voluntary residential time of use program back in 2016. From their sample, we gathered data from about 8,700 households, and we gathered the following data. We got monthly bills for all participating households for every year from 2014 to 2016. We also got hourly usage data for the same time period, and then we got survey data from after the pilot was complete. The survey data that I'm going to focus on in this study, they filled out measures of time of use acceptance, so their intentions to remain on their pilot time of use rate after the pilot program ended, their perceived and actual understanding of their time of use rate. So they both rated how well they thought they understood their rate. And then there was also a quiz to assess, were they actually correct in understanding when the on and off peak hours were happening. And we also gathered data on their perceived ease of shifting their on-peak use. And so by gathering both observables, so the actual changes in bills usage and understanding, as well as perceptions, we can see kind of what weighs more heavily in people's decision to continue on the time of use rates past the pilot. And I want to mention that we looked at summer months only. The pilot was such that households could enroll on a rolling basis, and everyone was enrolled by the summer. So we looked at the summer months only. Additionally, given the geographic location, that enabled us to look at cooling months. So when people are running AC because it's hot, we focused on that time period versus prior work has generally focused on what's going on when people are in a heating season, so when it's cold. Okay, so hypotheses, number one, we thought that perceived savings would be weakly related to actual bills and usage changes. We thought perceived savings would be a key driver of time of use acceptance over and above actual monetary savings that people achieved on the pilot program. And we also thought that perceived ease of shifting use would be stronger in predicting time of use acceptance than actual changes in use. And similarly, that perceived understanding of their rate would be a stronger driver of acceptance than actually understanding their rate. Okay, so for our first hypothesis, we're looking at associations between perceived savings and actual changes in bills, as well as on peak use. And here we're looking at the bills, and we see that there is a significant yet fairly weak relationship. Changes in bills is on the y-axis, and perceived savings is on the x-axis, and it is a fairly flat line. And we see a similar pattern of results when we look at perceived savings related to on-peak use. So people are not good at knowing how much they actually saved. For our next set of hypotheses, we ran a regression model looking again at how perceptions compare to observed variables in predicting the household's willingness to remain on the time of use pilot after the pilot ended. And again, we had perceptions of savings, ease of reducing their on-peak electric use, and understanding of rate. Then we had the observables matching those variables, and a bunch of control variables that we know are impactful on people's electricity use and bills, as well as their willingness to change electric rates. And so first, we see that by far and away, the strongest predictor in our model of TOU acceptance was perceived savings. So the more people thought they were saving, the more likely they were to stay on the rate. And this was a much larger effect than the influence of actual changes in bills on their willingness to accept and stay on the rate, as we can see in the lighter teal bar. These are standardized coefficients, so we can compare directly across them. Now, when we look at reducing on-peak use, we see that there aren't big differences between these two variables. Perceived ease of reducing on-peak use and actual percent change in on-peak use both had fairly weak effects, though significant, on acceptance. And then when we look at rate understanding, sort of interesting results here. The more people thought they understood their rate, the more likely they were to want to stay on it. However, the more they actually understood it, the less likely they were to stay on the rate, though a smaller relative effect size. And so in summary, there were fairly weak relationships between how much people thought they were saving and how much they were actually saving. And the perception of how much they were saving was the strongest driver of willingness to remain on the time of use rate in the model that we looked at. And we also saw that generally perceptions had stronger effects on time of use acceptance than the observed variables that they corresponded to. So the policy implications for this, well, as some of you may know, time of use is now the default rate for California residents who are customers of one of the investor-owned utilities. And so this is really a widespread program. You can opt out, but we know defaults are sticky. So not too many people are going to opt out. And our results indicate that, number one, people have inaccurate perceptions of how much they're saving. And number two, that these inaccurate perceptions can negatively impact household finances, as well as undermine the goals of these programs ultimately, since people may not actually be cutting down during the peak. So one thing to focus on going forward, we might focus on measures to improve energy literacy, such as simplifying the rate schedules or providing real-time information to indicate to people when their rate is being changed to the on-peak time. In the pilot that we examined, they got written or web materials to let them know. They got stickers to put on their fridge to let them know when the on-peak hours were, but nothing in real time like a phone alert or anything. And these results were covered by several media outlets, including the ones shown here. Okay, are there any clarifying questions before I move on to the second study? Okay, I will move on then. So based on data from the same pilot, we kind of shifted gears and looked at demand side response from an energy justice perspective. As I just mentioned, demand side response measures are becoming much more widespread, such as the statewide mandate in California, and this can really raise energy justice concerns because we may be disproportionately burdening vulnerable households who are forced to make trade-offs between spending money on energy versus other necessities, which is sometimes known as the heat or eat dilemma. And so we define energy poverty as a state of being in which households face the inability to meet both energy and other necessary costs. And energy vulnerable households face more intense energy needs and a limited capacity to adapt to changing circumstances, such as new rates. So you can imagine somebody with a disability running critically necessary medical equipment. They may be thinking, you know, I am approaching an on-peak time, and so I can either save money by unplugging my equipment, or I can incur a higher cost on my bill. Not a decision that anyone should really be having to face. The energy injustices faced by energy vulnerable households are many, spanning from procedural injustices such as limited access to information and policy participation to recognitional injustices, not being recognized or respected or represented by decision makers. And these findings were also published in Nature Energy with my former postdoc, Lee White. And in terms of vulnerability, we looked at a number of different groups based on prior literature. And so in our data set, we looked at individuals who are low income based on their enrollment in a utility financial aid program was how we defined that. We also looked at elderly individuals. So if somebody over the age of 65 resided in the household, elderly individuals require a narrower band of temperatures to remain comfortable and healthy. Additionally, we looked at households with young children, households that included a member who had a disability, and then also households that had individuals who identified as Hispanic or African American, as previous literature has indicated that those individuals can also fall into energy vulnerable groups and be subject to energy injustices. So our hypotheses were the following. Number one, we predicted that vulnerable households would engage in greater efforts to curtail air conditioning on time of use than their non-vulnerable counterparts. Number two, we predicted that vulnerable households would see a smaller decrease in electricity bills relative to controls and non-vulnerable households. And then number three, we predicted that vulnerable households would be more likely to require medical attention for heat-related reasons than their non-vulnerable counterparts. And so methods, again, we use data from this large California utility-wide voluntary residential time of use program that was conducted in 2016. It was an experiment. And so we got data from upwards of 5,000 houses who were randomly assigned to a time of use rate or to just remain on their baseline rate. And we got data for 2014 to 2016 for bills and hourly usage. We also got survey data from after the pilot that included demographics, reported efforts to curtail air conditioning use, and also people reported if they sought medical attention for heat-related issues. And again, we examined data from summer months only, which is why heat-related conditions were relevant here. So our first hypothesis to test this, we looked at whether vulnerable households reported engaging in greater efforts to curtail air conditioning than non-vulnerable. And we see that for several groups, this is the case. So if you were a low-income household, if you had young children, or if you identify as Hispanic or African-American, you are engaging in greater efforts to curtail AC use than your non-vulnerable counterparts. And you can see the effect sizes range from fairly small, 0.16 to 0.35. And this just means that if you happen to be low income or in one of those other vulnerable groups, you're making greater efforts to reduce your AC use than if you do not identify as one of those groups. Now, on the other hand, we see that elderly individuals actually engage in fewer efforts to curtail AC use than non-elderly individuals. So that's just another thing to note there.
Nicole, quick question.
Yes.
Are you, is this taking advantage of the experiment at all, or is it just, regardless of which group they were assigned to, you're looking at this, or is it of those assigned to the time of use?
This was actually only people in the time of use.
Okay.
Yeah.
But there's no experimental condition being manipulated here. It's more just descriptive.
This is more descriptive, yeah.
Gotcha. Okay, great, thanks.
But for our next hypothesis, we do take advantage of the experiment. And so we look at whether vulnerable households would see a smaller decrease in electricity bills than controls or non-vulnerable households. And unfortunately, across all vulnerability indicators, we saw that people assigned to time of use actually saw larger bill increases than controls. So people assigned to time of use are paying higher bills in this pilot. And when we look at different indicators of vulnerability, there were a couple of groups for whom, if they were assigned to time of use, they saw smaller bill increases than their non-vulnerable counterparts. And this was low income and Hispanic households. Versus there were also a couple of indicators where we saw the opposite. So if you have a member of your household who has a disability or who is elderly, you saw a larger bill increase on time of use than your non-vulnerable counterparts, or if you were assigned to control. So a mixed bag. Next, we're looking at health outcomes. So here we're just looking at a main effect. So we're looking at, do vulnerable households, are they more likely to require medical attention for heat-related reasons than non-vulnerable households, not taking into account the experiment. And we see that this is the case for people who are low income, those who have a disability, or those who identify as Hispanic. If you are vulnerable on one of those indicators, you are more likely to seek medical attention for heat. Now, when we take into account the experiment, we see that those with a disability or with a Hispanic household member, if you're assigned a time of use, you're more likely to require medical attention than controls. If you have young children, you're less likely. So again, some sort of mixed results here across vulnerability indicators. And just to sum up the main findings, households that were low income had young children, Hispanic or African-American members. They reported greater efforts to reduce their air conditioning use than their non-vulnerable counterparts just across the board. Now, when we take the experiment into consideration, households with elderly and disabled residents saw greater bill increases when they're assigned a time of use versus the controls and the non-vulnerable counterparts. On the other hand, if you were a low income or Hispanic household assigned to time of use, you saw lower bill increases compared to your non-vulnerable counterparts. And then when we look at medical outcomes, households that had Hispanic residents and those with disabilities experienced worse health outcomes on time of use versus control rates, while households with young children reported fewer trips to the hospital or fewer need for medical attention than non-vulnerable counterparts or controls. And so policy-wise, Well, the first thing that we noticed was that the time of use pilot resulted in bill increases across the board, which clearly has implications for consumer welfare and the goals of the program. So at a certain point, people may notice that their bills are increasing and then drop out of this program, which would undermine the program goals. Additionally, we saw that different groups have different capacities to respond to the time of use rate. And based on these findings, we would not recommend a one-size-fits-all approach. We think that these findings suggest that potential new rates should be tested very vigorously, including separate evaluation of impacts on different groups. And the results also indicate that people who are elderly, have disabilities, and/or who are members of minority groups really deserve particular attention in future pilots and policies so that we don't end up exacerbating energy injustices or creating injustices that did not previously exist. And these findings were covered by a number of media outlets, including the ones depicted here. And so just to kind of follow up on some more recent work, what I've been focusing on has to do with interpersonal dynamics of households and other sustainability consumption choices. And one thing that we've looked at has to do with the fact that current paradigms are focusing on a single individual or household level, such as utility bills, as we did in the work that I just presented. But 72% of US households are multi-occupant, and it begs the question of how families navigate household energy decisions. So for instance, many decisions like how high you're setting the thermostat or what food to buy are not made independently by individuals, but rather by multiple people through the process of conversation. And so one of our studies looked at how people navigate thermostat decisions. And we looked at the role of gender using a diary study of homes in Columbus and found that men tended to report more agreements and compromises when it came to deciding where to set the thermostat, whereas women trended towards reporting more conflicts. And we saw that agreements were more likely to result in thermostat changes. So the story sort of hints at women winning the thermostat war and women losing, although our data don't conclusively say that. It is something we're following up on in some current lab studies. Additionally, we just had a paper published with my co-authors, Grant Donnelly, who's in Fisher, and Kristen Hurst, my former postdoc, who's now faculty at Southern Illinois University. We looked at the effects of peer-to-peer conversation on sustainable behavior. And one highlight I want to share is our findings on partner stance in this process. And this has to do with the fact that our behavior after a conversation is influenced not by our own stance pre-conversation, but also by our partner's stances. And we looked at this in the context of plant-based foods. And in this particular study from the paper, we had about 300 participants randomly assigned to converse with a Confederate who gave arguments either supporting or opposing plant-based foods. And amongst those who were initially unsupportive of the initiative, speaking with the supportive peer resulted in greater policy support for the initiative than speaking with an unsupportive peer. But there was no effective partner stance among those who were initially supportive. So we saw this nice interaction whereby people who started out supportive were not influenced by naysayers, whereas that was not the case for people who were initial naysayers. It did matter who they spoke with. And that replicated in a texting format as well. And so following up on this work, I recently received a grant from IGS Energy to better understand how couples navigate solar adoption decisions. And I'm excited to work on that over the next few months. Sorry about that. Okay, and actually that's the end of my talk. So thank you for listening, and I'd be happy to respond to any questions.
Great, time for questions. Looks like Rob has a question.
Hey, Nicole, I'm glad you brought up the third study because I was going to ask about that in the first two studies. The battles that go on within the household. Maybe a clarifying question for the second study. First, though, in terms of how do you classify the households? If there's an elderly person present at all, does that become an elderly household, or do they have to control the bill, or?
There has to be an elderly person in the household.
Okay. And are you thinking about extending this work to the role of children in the household too, who may not be part of the decision-making process, but certainly part of the utility consumption?
Yeah, that's an interesting question that we've wrestled with quite a bit. Because it's unclear, right, the extent to which children's preferences may or may not be given like equal weight in certain decisions. And so far we've excluded them because we aren't sure what to do with it. And we're just, sort of embarking on this work. It's a little newer. But I am curious because at some point, and I don't know what the cutoff might be, children's preferences are going to be weighted, equally heavily with adults.
Mm-hmm. Thank you.
I have a question I'll ask about the first study. So you talked about making perceptions more accurate as one of your policy implications. But I'm wondering if you actually see, like, if it's actually the perceptions that are driving their interest or use in this versus the actual bills, is it possible that this could backfire? So if we educate people about what's actually happening with their energy usage, might you actually end up seeing, oh, wait, I don't need that. So are the people, are they actually fearful to your from the psychological perspective? Are they, fearful? Are they actually overestimating the costs associated with this? And that's driving the behavior. And so if we educate them, is there a chance for backfire? I mean, how much, do you have any sense of that? Like,
there may be, because we did see that the more people actually understood their bills, the more they actually understood their rate, I should say, the less likely they were to want to continue on time of use. So that could happen. I guess my personal view is that I don't think that it's good for consumer welfare to rely on people being inaccurate, or I don't want to say tricked, because that's certainly not the intent at all. But to the extent that people can be correct and understand and like really know what's going on, and that drives their decision making, that's usually going to be the better bet from a consumer welfare perspective.
Yeah, that makes it, particularly in light of your second study where you're seeing that actually they pay more if they're on. How much, the substantive, that was my second question, the substantive for the second study, how much more are people paying that are assigned a time of use?
I don't know off the top of my head, but I can look it up.
Yeah, thank you. Follow up on this. How stable is the benchmark expenditure? It's because if we assume that the time of use increases, might not be affected by a large increase in the sort of baseline or stable consumption. We've seen that recently with sort of energy prices in Europe, that this is a highly relevant study. But if we don't know how that effect changes the general effect, you trace it from two, it's obvious to make a follow-up.
So is the question like how variable is the baseline rate?
Yeah.
Again, I would have to look, but we did account for in the first study their baseline bills. And the second study used a triple difference model where we also controlled for baseline.
Somewhat naive question. It reflects that I don't look at my own bills enough. Are these always linear prices, or do they have like some convexity? I'm thinking about the injustice part.
Yeah, they were linear. In this study for the control rates, the time of use rates had, the increase during the on-peak and off versus off-peak times. They were not variable, and it wasn't like a stepwise rate whereby if you use more than a certain amount, you get, taxed essentially. So there may be different results if those were the rates being used.
And is it well known how people respond to those sorts of rates?
Like the dynamic and the stepwise?
Yeah.
There's been some work on dynamic time of use whereby the price varies in real time. I'm not super familiar with it other than the fact that it does tend to reduce on-peak usage. I don't know what it does to overall usage or overall bills, but on peak, it does tend to work as intended. The stepwise rates, I'm less familiar with that literature.
I have a question as well. I wanted to ask about geographic variation. Where the program was offered, did rates look the same across all areas, and also particularly by areas with different types of energy and infrastructure? Another like connected part of that is, I assume some areas just have better secondary locations, in the sense, for example, there might be more libraries with ACs in some communities, where if it's a very like particularly hot day, instead of using the AC in your house more, you might just say like, let's everyone get out. Go somewhere else where we can all gather as a community, for example, but different areas will have differing amounts of those types of locations as well. Do you have any thoughts on that?
Yeah, everyone had the same rate, so it didn't vary based on geography. We did do an analysis accounting for geography, and the results replicated. So because of the range of customers, I'm trying not to say too much. The utility covers a wide swath of customers in the state, who all have, varying climate zones, like pretty drastically varying. And so it was important to account for that, and we did, and the results did not change substantively.
Thank you.
Good question. Were the people assigned to the time of use group, were they given, I mean, I'm sure they were told that they were, a part of this time of use, like that they would actually, did they have information about when to reduce their consumption in order to save money? Like what was the messaging provided to that group, I guess? You've been assigned to the time of use group for study 2. What do you know? What do you learn?
Yeah, so they were given like mail or emails to indicate when their on-peak rates were, as well as a refrigerator magnet to indicate when their on-peak rates were. But that was about it. So it was fairly minimal, in my opinion. I think more could be done, but it was a pilot. So they were seeing, if we just give people the basic information, and it was corresponded to how they preferred to receive bills. So if they were, online billing only, they got emails. If they were paper billing only, they got actual physical mail with the information. I don't know that it gave them like tips on how to reduce. I also don't know that that would particularly matter, because that's just information, and it doesn't necessarily equate to motivation. I think the thing that I would, I guess, take lessons from moving forward is like providing real-time information, or like enabling phone alerts or something like that, so that people know in real time, okay, now is when my on-peak time starts, and so I should avoid, running the dishwasher or doing laundry right now.
Do you know if there's any studies that are trying that? I mean, that sounds super smart and totally a doable intervention. Curious if anybody's.
I have heard that there is some pilot that's using some sort of like light that turns different colors based on the price rate that's happening right then.
Do the smart thermostat, I know there's like this smart thermostat thing that AEP has here in Columbia. Is that at all? I mean, this is my naivety about this area, but is that related to this at all? Do they have different rates for different times of use, or is it just? I'm not sure. I would guess probably not as a package. I think you can get a smart thermostat regardless. AEP may also offer time of use rates, but it may be, you can do either or both with the smart thermostat. I think it would be wise to be able to program a thermostat such that it could be set in an energy saving mode during your on-peak time, but they don't come set like that.
that's the other problem with some of the technology is like, it's there, but you would have to set it to correspond to your rate.
Ah. Any questions online? There's thoughts? Yeah.
Quick question.
Brian.
Again, not knowing too much about this area, what was this a stated policy objective here to get consumers to internalize these things? Or was it more just, we want the prices to reflect the societal cost? Or is it a bit of both?
So this was a California Public Utilities Commission mandate that all the investor-owned utilities had to follow to switch to residential customers being on default time of use. And I don't know the whole background, but much of it does have to do with the fact that solar generation is becoming a larger percentage of the portfolio across the state. And in order to take advantage of that, we have to shift people towards using energy when the sun is shining and when generation is available, and away from that very high on peak early evening that happens that would require conventional energy sources.
Interesting. I mean, it's kind of like your study is showing, in fact, that I mean, do you know if they're actually reducing their energy consumption? Their prices are going up if they go on time of use. But is that just because the cost is so high for time of use that they're still maybe on the margin reducing their consumption a little bit? Or is it like they're not behaving rationally at all? They're not even reducing their
Yeah, they did reduce somewhat, but like not very much.
and then the tax is just so much higher from the time of use. That's increasing.
Yeah, and I guess the other thing to think about is there could be potential rebound effects whereby people may reduce their peak usage, but then at other times of day, use as much as they want. Maybe they feel like, okay, I've reduced when I'm supposed to, and so I've saved money, and now I'm gonna just use as much energy as I need. And so it's going to contribute to your bill, even if it does cut down on the peak.
Interesting.
This shows that people should just work at night, right? Because it's very difficult to change the pattern at around 6 o'clock. You need to eat, right? You need to cook.
To eat, yeah.
Yeah, your kids come home.
Yeah.
And the house in California is just very hot. Yeah.
Well, and this is also demand minus renewable supply. So at 6 o'clock, there's no more sun.
Yeah, exactly.
Yeah. Any other questions or comments?
I have one.
Yeah.
So you've asked that, I think it's a very good idea to show where this has been cited, but if asked by journalists to link the two studies, the perception study and the rate study, what would you say?
I'm very focused on the vulnerable groups. I feel like there's just not enough attention in utility work in general on subgroups. What often happens, as people may be aware, is that utilities will run these pilots or run a full program and then contract out the evaluation to some third party. And there is an incentive to show the results that we want, right? And so looking at who the winners and losers are may not be popular. It may not be in the budget. And I think that that's what needs to happen, because if, we don't want to see things like this. These are real consequences that people are experiencing, as well as just bill increases. And if we don't pay attention to who the winners and the losers are, we miss this. So I think regardless of what people perceive, we need to be looking at what consequences people are experiencing based on their membership in different groups.
A quick question, I think, because we're on the slide too. How did you differentiate between heat-related reasons for calls versus other things, and how might that have also shown up versus? I see Actually, yeah, I'll keep my question to that. Like, how exactly did you parse it out? And were there also just a gradient of outcomes? For example, was it just something like, I mean, there are a lot of different types of heat-related reasons to call an ambulance, and it can look different for different people as well.
So this was a binary question of if they required heat-related reasons, or not, required medical attention for heat-related reasons or not. And it didn't ask them, like, did you require medical attention for other reasons? It was just like related to heat during the hot summer that most of the climate region experienced. So yeah, I mean, that question is a little bit, I guess, gross or rough. It could have been more detailed, but it was what the utility collected and what we had access to.
Thank you.
Did you convince the utility to do the experiment, or was this something that they were just, as they were rolling it out, it was kind of almost, they build in a natural experiment into the rollout where everybody eventually was going to end up on this, but they were willing to kind of tier it so that they could evaluate the effects? And then I'm thinking about, I loved your focus on these heterogeneous treatment effects in these vulnerable groups. I know sometimes, you know, if you don't design that in a priori, you don't have enough power in those cells to do with this kind of a thing. So I wonder how you thought about that as it was kind of rolling out.
So this was already planned by the utility. It was going to be done. I'm not sure if CPUC mandated this pilot as well. I wouldn't be surprised if that was the scenario. We had no involvement in that. We were just able to collect the data after they completed the study. What I really would like to get is if people stuck on the time of use now that it's mandated. And now, unfortunately, since I've moved to OSU and no longer have access to the data through my previous institution, OSU legal does not want to agree to the terms that the utility requires to share the data. So I'm not able to access that data. Yeah.
No, that's terrible.
Yeah.
I'm sorry. On behalf of OSU, I apologize. Not that I can do anything.
Appreciate it.
But this idea of heterogeneous treatment effects, I mean, I'm serious, like I worry with experiments, you know, we often worry about like this dance between, like, I really want to explore those heterogeneous effects. But then if I didn't a priori think about that when I designed, and in this case, you're benefiting from an you couldn't change the design, right? Or the rollout, or how many people were assigned to those conditions. So is it just kind of relying on there being enough power in each subgroup to be able to do?
Yeah, this was a very large pilot.
Yeah.
I don't remember the total number of homes that were enrolled, but we had very large cell sizes, even when we looked at these subgroups, which I would have expected to be smaller. There were several thousand in each.
Yeah, that's great. Awesome. Anything else? Anybody? Questions? Comments? All right. Well, thank you, Nicole, for your time. This was fascinating, great research, and I look forward to being in touch.
Thank you so much for having me. Appreciate it.